Hello Year 7. Hopefully when you return to school you will be having your test on solids, liquids and gases if you haven't already done so. In the meantime, this lesson is what we call a retrieval practice lesson, and its objective is to recall the properties of solids, liquids and gases and begin to use these properties to help us explain the particle theory and to explain how the particles are arranged in solids, liquids and gases. You will need for this lesson some paper and a pen and pencil. None of this work is in your booklet, so the booklet hopefully should now be completed. If not, make sure that you go on to Moodle and you do the additional lessons that were set during the lockdown period to make sure that you have completed this topic. And that test will be on your return whenever that is. So, little starter activity. We've got some yellow statements on cards here. We would normally have these on card to give to you in groups, and we'd ask you in your groups, okay, to sort them into 3 piles. A pile with statements of properties of solids, a pile with statements for properties for liquids, and a pile for statements of properties of gases. So what I would like you to do on your piece of paper is to create yourself a table with 3 columns and to write the statements into the correct column. So put solids on the top of one, liquids on the top of another, and gases on the top of another. Pause the video at this point to give yourself time to write these down. So hopefully you've had a chance to put those into their appropriate columns. If we turn to the next page on the sheet, you can see the answers. So solids all have a fixed shape and cannot be squashed. However, liquids can flow but still cannot be squashed. And gases can flow and be squashed. With solids, some are hard and some are soft. With liquids, they can change the shape and take up the shape of the container that it's in. With gases, some are clear. Solids, if left, will keep their shape. Liquids can be coloured and some are see-through. Gases are lighter than the other states of matter. For solids, they always take up the same space and it has a fixed, that should say volume, at the bottom there. It's been written on the other side, so we'll just write that on there. A fixed volume. Liquids, if in a sealed container, will keep their volume, and gases can change their volume to fill a container. So that's why the word volume was there. So mark how many you had correct. There are a total of 12, and give yourself a score out of 12. If you have 12, well done, superb work. 10 or more, you're doing really well. 8 or more, well done, you're making a good start. And 6 or more, okay, you're doing very well. So our next little activity that we're going to do, put the title, the Kinetic Theory of Matter. And as we explained, we're going to use the particle model of matter to describe solids, liquids and gases, and to also explain the properties. So I've got another little starter quiz for you to do. This is called a true-false quiz. And the ones that are false, I want you to correct them. So we've got some keywords over here that you may want to use. So the word particles, solids, liquids, gases, compressed and volume. So our first statement, there are 4 states of matter. Write it down. Do you think it's true or false? Number 2, the particles in a gas are far apart. Do you think that's true or false? Number 3, an example of a solid is ice. Is that true or false? Liquids take the shape of their container. True or false? And number 5, an example of a gas is lemonade. True or false? A little challenge. How does a solid turn into a liquid? And can you think of an example? So I'll give you a few moments. See if you can write down how a solid turns into a liquid. What does it need to do that? And what happens in the particles? And can you think of an example for me? and then we're going to go over these answers. So, on my next page, 1 and 5 are false. There are 3 states of matter that we teach you at Key Stage 3. You may have heard of plasma, okay, but at Key Stage 3 we teach just 3 states of matter. The particles in gases are far apart. That's true. An example of a solid is ice. That's also true. Liquids take the shape of their container. That's also true. But number 5, an example of a gas is lemonade. That is false. There is a gas in lemonade. Can anybody think of what that gas is? So the gas that is dissolved in lemonade is carbon dioxide. And that's what gives our fizzy drinks their fizz. Okay? So, if you had 1 out of 5 or 2 out of 5, you're in the red. If you had 3 or 4, you're in the yellow. Well done, those of you that had 5 out of 5. Diane. So, we want to get you to start thinking today. The bigger picture. How does a packed football stadium resemble the particles in a solid? If we look at all the little people sat in this stadium, so the ones closest to us we can actually see their heads clearly, but the rest of them all look like little dots, okay? What do you think the football supporters represent? So when they're all packed in tightly together like this, and they're not moving, they look like the particles in a solid. So they're almost all touching one another, certainly not socially distanced. And they're in nice, neat patterns. So this is how the particles in a solid are represented. If they were in a liquid, there might be less visitors to the stadium, and they might still be touching one another, but there might be a few empty seats. Depends who's playing. So the liquid particles can still move around one another, but they're still attached. If this was a really awful game to watch, then there would be hardly any supporters in the stadium. There would be big spaces between them, and they would be allowed to move around a little bit more. So the football supporters are like the particles in a solid. Each person has a fixed place, and the people next to them do not change. The supporters have a little space between them and are all in neat rows. So how would they be arranged? In a liquid and in a gas, as we've just described. Now, the next task we would normally get you to do in groups of 3, but I'm going to ask you to be doing this work by yourself. So you're going to have a worksheet, and your worksheet looks like this, okay? So because we haven't got the worksheet to hand out to you in class, what I would like you to do is to draw yourself another table and to give yourself 3 columns. So you can turn the page landscape if you want, as opposed to portrait. In one column, you're going to have solids, in the next one, liquids, and the next one, gases. To save you having to write out all of the questions, we're going to call the top question, question 1, question 2, question 3, question 4. So I'll put those numbers in. So all you're going to have to do when you come to complete this task is write the numbers and your answers next to them. At the side here, we can see L3, L4, L5, L6. The L stands for level. So if you could name me 3 solids, 3 liquids, 3 gases, that would get you around about a level 3. If you could draw me a particle diagram to show the arrangement of particles in a solid, liquid and gas, that would get you a level 4. And if you could describe the properties of the solids, in other words, how they behave, and liquids and gases, that would be level 5. And the hardest one, level 6, is explaining how the properties of a solid are linked to the arrangement and movement of particles, and then also how the properties of a liquid are linked to the arrangement and movement of particles, and finally the properties of a gas linked to the arrangement and movement of particles. So spend some time just sketching out the table. Use a whole sheet of A4 if you've got that, or a page in a book. And I want you to fill in as much as you can. So pause the video at this point. Have a think around the house. If you're going to go looking in cupboards, be careful please in the kitchen, especially with things like cleaning materials. But have a look around the house for examples of solids, liquids and gases, okay? Use your booklets to help you answer the level 4 questions about drawing particle diagrams. And your booklets will also help you to answer the level 5 and level 6 booklets. If you're still struggling, have a look at some of the videos that we put onto Moodle for the last lockdown, the Oak National Academy videos, and they will help you to describe the properties. Pause the video. So when you've completed your table, if you can name 3 examples of a solid, liquid or gas, give yourself a tick for each one if you think you've got them right. If you can draw your particle diagram, and they should be in a solid, as we described, they should be arranged so that they're all in a nice, neat row, like the footballers in the stadium, packed together tightly, not very much room between them, then that will get you a tick for your solids. For liquid, not so neat, still touching one another, but able to flow and move around one another, so have a bit of space between them. And for our gases, lots of space between them, and these particles are moving constantly, so sometimes in cartoons, in animations, we put some little dashes to indicate there's movement. For describing the properties of solids, liquids and gases, turn back to the little squares in the beginning of your book on SLG to see if you've got all of the properties of the solids, the liquids and gases, or you can go back to those little yellow cards at the start of this lesson to see if you've got some of them written down. And as I said, this hardest one, level 6, okay, is about explaining these properties, how they're linked to the arrangement and movement of particles. So solids are quite hard, they're difficult to change their shape, they have a fixed volume because all the particles are packed closely together with tight bonds between them. Whereas liquids, there are less bonds between them, they're still attached, but they can flow and they can move over one another. So it's easy to pour a liquid and a liquid flows. Gases, however, they will fill the space of the container they're in because the particles have no connections, no attachment to one another. They have lots of energy and they're moving around rapidly. Take another sheet of paper then, and we've got 3 beakers. Take a ruler or a straight edge to help you draw the straight lines of the beakers, and I want you to draw me a lovely picture. You can use any colour you like for your particles, but I want you to try and keep your particles exactly the same size, okay, in both solids, liquids and gases. And so I want you to draw for me, for example, in the beaker containing the solid, a cube, an imaginary ice cube, but we want to see how the particles are made up in our imaginary ice cube. So if we were going to do it 3D, we would be able to see the particles making up the cube 3D. I'm afraid my artwork is not particularly great there. And then I want you to draw them for a liquid and for a gas. And then I want you to name me some solids, so things like ice, okay, chocolate, one of my favourites from over Christmas, okay, liquid, we could have water, we could have petrol, we could have washing up liquid, fizzy pop, anything you like. So I want you to illustrate this like a poster, and then gases, oxygen, hydrogen, carbon dioxide. These are some of the ones that should be familiar that we've looked at in class. And I want you to illustrate it and make it look really pretty as a poster. Put your name on it then, so that when you come back to school, we can stick that on the front of your booklet and use it for revision. So imagine now the substance is poured out of the beakers. What would your particle pictures look like now? So I want you to draw how the particles would be as they were being poured out. So would they stay together? Would they separate? Would they flow? Would they move? So pause the video, draw me a quick sketch of what you think the particle pictures would look like. Now finally, at the end of the lesson, this would normally be peer assessment because you'd be working together in groups of 3, so this is going to be self-assessment. What I want you to do with both your sheet where you described all the level 3, 4, 5 and 6 questions for solids, liquids and gases, I want you to have a look and check, have you covered these things? Have you got that in your diagram all the particles are the same size, all the particles are touching? Are they arranged in ordered layers, not like my diagram earlier, which was rubbish? And the substance has a fixed shape. Have you, in your self-assessment for the liquids diagram, have all the particles the same size? Are they touching at least one other particle? Are they randomly arranged and the substance does not have a fixed shape? And then finally for gases, all the particles are the same size. There's no particles touching. The distance between them might be about 10 times the diameter of each particle, depending on how big you've drawn your particles. The particles may have arrows or like movement, dashes to show movement, and the substance does not have a fixed shape. What I want you to do then at the end of this lesson is I want you to write your what went well, your WWW, what you did do, under each picture of your beaker. And then I want what you could have done to improve it, if it needs improvement, your EBI, even better if. So I want 1 what went well, so you can use these statements if you like, and 1 even better if for each of the solids, liquids and gases. Keep that work to hand, actually put it inside your booklet because it's a really good revision lesson for when you will have your test on your return.